right, thank you. Thanks for having me. So I'm going to give you 5 minutes. 5 minutes to explain the whole history of blockchain architecture. It's going to be a lightning thing. It's not going to be difficult. It's going to be diagrams. And let's walk it through. Okay, a little bit of history lessons. So Bitcoin was the first ever implementation of the blockchain. Now, he didn't really say it, but there are 3 key things that everyone who jumps into blockchain needs to think about in terms of how architecture is designed. So firstly, you have state. So state is like how much money do you have, what has happened, is it a yes or is it a no for a contract, stuff like this. You have block space and processing. So what that means is you have state, but this state needs to change and you collect transactions. And these transactions then need to walk through its path towards a new state. So you do need some kind of a place to put these transactions, and you need a place to put these transactions on the chain so that everyone can see. In Bitcoin, it was always that same one node at a P2P level, that same architecture that's shared across many, many, many nodes. And essentially, the third part is, okay, we have a state. This state is moving over time. We call that blockchain. And then the third thing is which chain, which what we call fork rule, which chain is the truth of the data. And we call that consensus. You can think of it this way. There are true finite concepts in life. There's capital that's finite. There's machines that's finite. So one way or another, with finite machines or capital that's going to vote on which is the true state of things, that's the way forward. And you can see that large area is kind of like how much that capital or economic security is. So over time, like people were like, okay, let's find more use cases. So and when they did that, you know, they just like initially it wasn't too interesting. So things were like, you know, just fork Bitcoin, implement similar ideas around state transitions, block-based processes, and crypto economic security. Now, that's where Ethereum comes in, right? So that's where crypto economic security has a very new lens, right? So crypto economic security is not just about the stake that's been done by validators. Now, with applications that live on the chain, that state actually on the application level with ERC20s and all sorts of different assets, fungible assets, non-fungible assets, they become like new areas of crypto economic capital that has to be secured by the fundamental layer. That's where we talk about rollups, right? So rollups is where that fundamental capital that sits on the L1 then gets into a position where, okay, it's kind of like being used to choose forkfulness of the layer 2 rollup. So you would think that the layer 2 itself, there's also a block space and coprocessor, there's also a state, and that state requires some transaction function across a set of blocks. Yeah, and initially this was really expensive because we put all data into what we call call data, and that's on a place right directly onto Ethereum. Subsequently, we developed this thing called Blobs, which is kind of like a data layer that's a first-class citizen, where it's sort of like a separate fee market from general transactions, and it only lasts for like a short period of time, a bunch of weeks, before it's destroyed. So that way you can prove things with these blobs to move the chain forward, but you don't need to keep all the data on chain. That's when we actually have new kinds of data availability as well. There are new L1s created like Celestia, which have their own state transitions, but their goal is to keep data temporary. That is sort of like, you know, and yet again looks like a fork. And then subsequently, we have like EigenLayer and Symbiotic and Karak, which then talk about restate capital, where then they use restate capital as a way to then create new protocols, and that creates things like a data availability on like EigenDA. Now, all this being said, made fees really cheap. So the issue is that all the L2s have really cheap, but what about the fees on the L1? So new types of designs like base rollup architecture help sequencing on the L1, so to collect more fees and MEV. And these things are like still in progress. The question is profitability of base rollups, whether this will be something sustainable over time. Yeah, but with that, it creates new ways to use the restate capital that I talked about. So you can imagine Ethereum is a 12-second block time, but you want a pre-confirmation and something that's really fast, just like the 2-3 second you find on Mantle network. And so the way to do it is like restate capital from EigenLayer and Symbiotic that can then be included in some kind of an inclusion list. Yeah, with that, that's where we are. Inclusion list, base rollups, question mark, standard rollups, L2s, optimisms, and validiums are different kinds of ways for off-chain data. And we are truly an infinite garden where there's so many architectures. This ecosystem has so many, and we will continue to push the best architecture for this ecosystem. Thank you.
Wow, that was on the spot. We are going to take a couple of questions for this session, so you can ask them through the application, or you just raise your hand and ask, and I'll repeat into the microphone. So, does anybody here have a question? Okay, if not, they can find you later and ask you anything.
Thank you.
Thank you a lot.